microphone. Just give me 1 second. Oh yeah. Now is it fine? Now can you guys all hear me? Sorry for that. Now can you guys all hear me? People in the platform as well. Can you guys hear me? Hi people. All good now? All right. Okay. All good? Awesome guys. Anyways, very warm welcome to today's session. I hope all of you guys are doing good and having a fantabulous day so far. So today, what we're gonna do is basically discuss some very important questions for all the 10th graders out there. We're gonna give you, you're gonna be giving your exams in the next couple of days. So this one is specially dedicated to you guys. Hello, hi, yes. Big screen. All right, so this one's specially dedicated to you people to help you understand, revise, and more importantly, recap a couple of things that you would have forgotten or maybe would have, skipped over the time. Maybe you'd have forgotten it. So we're going to revise those concepts and at the same time, try to solve some very important questions. And all the questions today are taken from previous year question papers. So if you haven't done that yet, if you haven't gone through the previous year question papers yet until now, this is a very good opportunity for you guys to see what actually is there in the previous year question papers, which actually does matter when it comes to your term 2 examinations. All right. So can I get a oh yeah in the chat box so we can get started? In the meantime, guys, just give me 1 second. Let me just sort something out. Apparently, there's no charge in my phone, and I'm a very active guy that I forgot to charge my phone. So just give me 1 second. I'll just sort this out. I'll be back in 1 second, guys. Just give me 1 second. Otherwise, no, I'll not be able to see your chat. Sorry for that. I'm back now. Yes, I'm back with the bang. All right, so let's get started, guys. Let's get started. All right, so give me oh yeah in the chat box, people. Come on down. What is this? No Josh only. Where did all this Josh die? Die. Exams are energy. What is this? Happening? I don't think anyone would do that, but I'm just asking anyways. No, all good, right? And why no Josh? Why no Josh then? Full Josh I want full Josh. Can't hear you again. Array, what is this, da? 1 sec. I'm talking to myself again. Now is it fine, people? Now is it fine? I don't know what is happening, guys. There's some sort of issue with my microphone. All good now? Array, what is this? Not audible? Still not audible? 1 sec. Yes. Now all good? Okay. Audible, no? Okay. Why confusing me, da? Why confusing me? All right. Okay then. So let's get started, people. Let's get started with today's session. Let's not waste any more of our valuable time. Let's get started. So exactly as I told before, today is going to be about 10 most important questions. Now, all those who are on YouTube right now, I'm just going to say a quick, very important thing to you people. Now, what you have to do is, people, go to the description of this video in order to join. Yes. So all you have to do is go to the description of this video in order to join the entire session on the Vedantu platform to experience what it is really like. So all you have to do is this, people, go to the description of this video, subscribe to the channel, hit the like button as well, and go to the first link that you see on the top, right? So just click on this, click here to join the session. That link will directly take you to Vedantu's webpage where you can, all you have to do is log in and you guys can take part in the session from there itself. So you can experience everything that you love about Vedantu's platform. All the quizzes and everything can be done over here on the platform itself, all right? So it's an awesome opportunity for you guys to actually experience what new wave of learning is actually like. All right, so with that said, people, let's get on to the questions now. So what I've done is basically, people, have divided the questions into 3 different categories. We'll start with the 2 markers, move on to the 3 markers, and then finally end up with the 4 mark questions. Now, 2 markers, as you guys know, is going to be very straightforward, very simple, very easy, both from electricity as well as magnetic effects of electric current. So without wasting much more of our valuable time, here is the first question on your screens, which was asked in 2008 CBSE Board Exam. The question is, out of a 60 watt and a 40 watt lamp, which one has a higher electrical resistance when in use? You have a 60 watt bulb and a 40 watt bulb. Which one would have comparatively higher resistance is the question. 2008 CBSE Board Exam question, people. Go ahead and answer it in the chat box. I want to see everyone putting down your answers over there. 40, obviously, so much confidence. Super. Arey, Simran ji, congratulations. Party. 40, pakka. Super easy question. Absolutely, guys. Let me tell you how to do this question. We know that P is equal to V into I. This is what we know. Now, we know that I is equal to V by R from Ohm's law. So, we can write it as P is equal to V square by R. So, that means power is inversely proportional to resistance. So greater the power, lesser the resistance. Here they are asking for which one has higher resistance, and hence the obvious answer is going to be 40 watt, because as the power is lesser, the resistance comparatively is going to be higher, and hence the right answer is lamp number 2, which is of 40 watt. Fantastic job, guys. Fantastic job. Big round of applause for yourself. Absolutely super awesome. Moving on to the second question for the day, people. Here we go on to the second question. Sir, how about we know voltage is constant? Okay, that is a very good question. See, here is the thing. Here is the thing. That is actually a very valid question. So this is also there, that P is also equal to I square R. This is also possible, like in a sense, current is constant. But here's the thing now. When you talk about lamps at home or any electrical connection in homes, we always connect them in parallel. The reason why we connect them in parallel is because we want the voltage to be same. And one of the other major advantages is that in parallel connection, even if one of them gets fused, the other one would continue to work. And that is very, very important when it comes to real world application. So when you talk about real life examples, in most cases than not, it would be connected in parallel. Now it's, you could connect them in series, but then in series, we know that even if it is, see, in series connection, the problem is if you were to connect a 60 watt bulb and a 40 watt bulb back to back, the 40 watt bulb, which is connected after the 60 watt bulb, will automatically have lesser brightness because the resistance is more. All right. So generally we connect them in parallel in real world, in your home, in my home, everywhere, in all homes, all over the world, we connect them in parallel. And that is why we are assuming that it is connected in parallel over here also. All right. That is the only thing. All right. Now, if they have particularly mentioned that current is constant, then directly go with this formula, because over here it says that power is directly proportional to resistance. Here, since it's not mentioned, we are assuming that they're connected in parallel. All right, that's a very valid question. That's a brilliant question. Absolutely fantastic. Good doubt. Round of applause for you. All right. Okay. Second question, 2009 board exam. Let's go for another one. Calculate. A very simple question, guys. Honestly speaking, I myself have asked this question 5 times already. I can do this closing my eyes right now. Just with my eyes closed, I can literally do this question because it is that straightforward and that simple. The question is, calculate the resistance of an electric bulb which allows a 10 ampere current when connected to a 220 volt power source. Such a straightforward question. I know, right? Such a lol question. Absolutely wasn't. That's a lol question because I myself, I've been pretty much all, whatever series I've come up with, whatever it is, this question has always been there. This question has always been there. Whichever it is, this question has always been there. But this again was asked in 2009 board exam. However, very simple, guys. R is equal to, according to Ohm's law, we know that R is equal to V by I. Just substitute the values, 220 divided by 10. You don't even if you're not good at math, this is such a straightforward, easy question that literally anyone can do it. 22 ohms is the right answer. Fantastic job. All right. Coming in a little closer now. 2013 CBSE board exam paper, yet another one. N resistors, each of resistance R, are first connected in series and then in parallel. What is the ratio of the total effective resistance of the circuit in series combination and parallel combination? You need to find out the ratio of their effective resistance, or you call it as equivalent resistance. Initially they're connected in series and then the same resistors are connected in parallel. What would be their ratio? Very simple question again. Let's go for this one, guys. N2, what is N2? 1:2, N square, all right, N to the power 2. Okay, anything else? Pakka? N:2, all right, 3. Very interesting answers and all, but yeah, it's very close though. 2, N:2, N by 2. A lot of answers very similar to that, but I'll show you how to do this. Now, initially people, they're connected in series. So RS, which is nothing but your series, equivalent series connection, is R1 plus R2, which now here there are N number of resistors, each of the same resistance R. So if you have N number of resistors with the same resistance, you can say it as N into R, where N is the number of resistors and capital R is the value of that resistance. Now here, you're also connecting them in parallel. When you have parallel connection, it is RP is equal to R by N. Alright, RP, that is nothing but equivalent resistance, is equal to R by N. Alright, where R is the value of resistance, N is the number of resistors again. Now you need to find out the ratio RS by RP. Again, substitute the values over here. NR divided by R by N. RR gets cancelled. N goes to the numerator. You can also write this as N into N by 1. You're taking it to the numerator. So this is going to be N square. The answer is N square. It's very close though. A lot of you guys are like, sir, N by 2, N is to 2, 1 is to 2. It's actually N square. Alright, not 4 is to 1 also. It's N square. Alright. So yeah, N square is to 1. Yeah, you can say it as N square by 1 or N square is to 1 is the answer. Alright. Close though, close. A small confusion. So you need to correct all that, because in these kind of silly mistakes, we end up doing a lot, especially, coming from a math background. I'm telling you, we all make these kind of silly mistakes. The more you practice, the more you can easily avoid these kind of silly mistakes. Alright. So the answer is going to be N square. Alright, viewers, so that is the end of the next question. Let's move on to the fourth question from, again, 2014 CBSE Board Exam paper. The question is, what are magnetic field lines? List any two characteristic properties of these lines. Very simple question. Again, I myself have asked this question a lot of times in the class, so I guess it's going to be very straightforward and easy. So go ahead and answer this in the chat box, people. What are magnetic field lines? Let's go. RNG, all I would say is this: go through your NCERT as fast as possible. Go through your NCERT. There are two chapters: electricity, magnetism. Practice the numericals of electricity, practice the hand rules of magnetism, go through the DC motor part, electromagnetic induction from magnetism and electricity, go through Ohm's law, and then practice the numericals, then heating effect of electric current, all of that related to that power, all of that. Go through that, you're good to go, at least. All right. So if you want to do it fast, this is the simplest thing to do. Go through all the major topics. Whatever is more important right now, please go with that. All right. Imaginary field lines around a bar magnet or an electromagnet originate from the north and the south pole. Strength depends on the degree of closeness. Wonderful answer, Discovery Science. Magnetic field lines are always closed curves outside the bar magnet. Magnetic field lines go from north to south pole. Fantastic. Imaginary lines that when it's where it is effect is observed. Okay, interesting. Any other answers? Magnetic field lines are imaginary lines representing the magnetic field. Magnetic field lines are the magnetic field. Okay. All right, similar, but well done, guys. Well done. Fantastic. Now, since it's a 2-mark question, you don't need to worry so much about it, because your answer that you've put down in the chat box itself is sufficient. But just to be on the safer side, I would tell you to put this as well. Magnetic field lines are imaginary lines which basically show the magnetic force around a magnet or a current carrying conductor. Now, you can also mention that the magnetic field lines always move from north to south, which can be donated or can be shown by using a magnetic compass. So if you take a magnetic compass, the north pole of the compass will always point in the same direction. Now, talking about the characteristics or any two properties of this, as you guys already mentioned, magnetic field lines always move from north to the south pole. That is one thing that you can mention. And secondly, you can also mention that magnetic field lines would never ever intersect with each other. Intersect intersect with each other. All right, with each other, because again, if two magnetic field lines were to intersect with each other, then there would be two different north pole at the same point, or there would be two different tangents at the very same point. Fantastic, guys, fantastic. Now you can also mention their closed loop. Absolutely, you can mention any two properties. It's totally up to you guys. As long as it is satisfying the minimum conditions, you would easily get those 2 marks. All right. Okay, moving on to the next question, guys. That is the end of the 2 markers, by the way. Now, people, before we go to the next one, can we have a big round of applause to each and every one of you guys for having such an amazing response in the chat box? Because honestly speaking, by the time I was reading the answers, you guys were able to actually put down the answers in the chat box. That is just fantastic, people. Keep up the good job. Keep doing the same thing in your exams also. Keep practicing these kind of things. The easier it gets. All right, fantastic, fantastic. Super awesome. Dol bajao ji, dol dol. Bhangra karna hai humko, bhangra. Let's go, let's go, let's go. Alright, super awesome. Alright, guys. So now, with the end of this dole, we'll move on to the the 3 mark questions, or the 3 markers. Now, 3 markers, as you guys know, will be a little bit more descriptive in nature. You might have to explain a little bit more, but again, try not to beat around the bush and try not to make a whole mess out of it. Please stick to the keywords, because at the end of the day, it's not English, it's physics. So stick to the keywords, be to the point, but you need to explain, be a little bit more descriptive, be a little bit more brief about it. All right, the 2 marker from 2018 board exam question. Here we go. How should you join 3 resistors, each of resistance 9 ohm, so that the equivalent resistance of the combination is first 13.5 ohms and then 6 ohms? A fantastic question. Honestly speaking, guys, this is really awesome, because again, this particular question, or these type of questions in general, it's a lot of trial and error. All right, you 8 and try method. So you need to try one particular a circuit diagram first, and if it doesn't work out, you need to immediately move on to the next one, because there is no way of telling what is what here. Now this one particularly is very straightforward, very simple, but if you have 4 connections, 4 resistors or 5 resistors, then it might become a little bit more tricky. But I'm hoping that CBSE will not put you through that. 3 is what I'm guessing, but if in case there is a little bit more, let's say there are 4 resistors connected in series or parallel, whatever it is, you need to be ready to actually spend at least 3 to 4 minutes on these type of questions, because if one doesn't work out, you need to immediately switch to the next one and then keep trying until you find the right answer. All right, so here's the first one, people. Let me know in the chat box what would be, or how would you connect these resistors in order to get an equivalent resistance of 13.5 ohms. So 2 parallel in and other in series. Arre wow, Sai Prerna, wow, what Josh. 2 9 in parallel and the other in series. And for the second one, 6 for 2 9 in series. Okay, my God, amazing, super awesome. All right, so the first one, guys, you need the equivalent resistance to be 13.5 ohms. I would say for this one, if it is 3 ohms, the first thing you need to always try is this one. You can try 2 parallel first, all right, 2 connected in parallel, and then 1 connected in series. All right, now all of them are of 9 ohms each. So when you calculate for this one, it is going to be, I'll take it as R1, take this as R2, I'll take this as R3. So I'll just change the color so that you guys can clearly see it. So here R12, 1 by R12 is equal to 1 by 9 plus 1 by 9, which is equal to 2 by 9, which is equal to 9 by 2, which would be equal to 4.5, because 2 4s are 8, then it's going to be 510, right? 4.5 is the equivalent resistance of this one. This one's equivalent resistance is 4.5, and the other one is connected in parallel. So the total R equivalent is equal to R12 plus R3, which is going to be 4.5 plus 9, which would give you 13.5 ohms. Very straightforward, very simple, very important. All right, because for sure there's a very high probability that these kind of questions can appear in your boards, because it's more of a practical application based question. And since CBSE is slowly turning towards an application based questions, there's a very high probability that this might come, or the similar type of questions might come in your boards. All right, let's go for the second one. Come on, people. For the second one, what do you think would be the best suitable one for this? Come on, let's go. I'm good. Hi, Harmanjyoti. What's up? Long time. Second one, 2 in series and 1 parallel. Okay, let's try that out. So 2 in series would be this, any 2 of them in series, and then both of them connected in parallel. Fantastic. Let's try to do this. So 9, 9, and 9. So these 2 are in series, so it's going to be 18. Right? 9 plus 9 is 18. And this one is parallel. So it's going to be 1 by 18 plus 1 by 9. So 9, 2. So 1 plus 3 divided by 18, which is equal to, 2 plus 1, which is going to be 3 by 18. So the final answer that you get, I'll just write it on the top over here, people. So final equivalent resistance is going to be 18 by 3. 3, 6 are 18. So 3, this would be the right answer. Fantastic, guys. Fantastic. Peed out of you guys. So peed out of you guys. Can we have a star shower, please? Because you guys are all, twinkle, twinkle, little star. That's right. Fantastic. 2 in series and the whole thing in parallel. Yeah, exactly. Now that's the connection for the second one. Fantastic job, guys. Absolutely fabulous. All right, so with that said, let's go on to the next question. So this is the answer for this one. Please do try, practice as many type of questions as you possibly can about this one, because you need to work on your time, how much time you're spending on these type of questions. All right, the next one is a superstar of a question. I'll tell you why. Because this beautiful question was asked in not 1 board exam, not 2, not 3, not 4, not 5, but 6 board exam back to back. 2010, 2011, 2012, 2013. Unfortunately missed out on it because 13 is a bad number, unlucky number. 14, 15 and 16 got this as well. So the question is, what is a solenoid? What a tough question. So difficult. How many of you guys are sweating through your palms after reading this? Next part of the question is, draw the magnetic field lines due to a current carrying solenoid. Sweat coming from your forehead now. Write 3 important features of the magnetic field lines obtained. Sweat coming through your armpit now. What a difficult question. No? What a difficult question. For 6 years back to back, they have asked this question. For 6 years. All right, 6 years. You can imagine how lazy CBSE board is. No offense, CBSE. No offense. Just bathing inside. No, I know exactly. Alright, what is a solenoid, people? Put it on in the chat box. I know. Like Kai and all, your hand and all is shaking, shivering now. Alright, let's go. Kai, it's my Malayalam accent is coming in. Solenoid is a coil insulated wire which has many turns and is of cylindrical shape. Fantastic. Solenoid is a coil in which large number of turns are there. All right. So coil with many circular turns of insulated wire. Fantastic. Any other answers? A number of turns in a copper wire is known as a solenoid. Fantastic, guys. Fantastic. You guys are all right. A solenoid is nothing but an insulated copper wire which is wound in a cylindrical form, which is wound to look or to resemble a cylinder. You can also mention that there are it's nothing but several number of insulated copper turns, insulated copper turns put together to make it look like a cylinder. Now, either of these two would describe the exact same thing. So please don't worry, don't panic. It's absolutely fine. CBSE would still give you marks no matter whichever way you pretend or whichever way you go with. Now, to draw about the magnetic field lines, it's very straightforward. You guys know it. The magnetic field lines of a solenoid is very similar to that of a bar magnet. You all know that. So it's probably one of the most easiest to draw. So all you have to do is draw the magnetic field lines on the inside, and then basically just like in a bar magnet, how the magnetic field lines are connected on the outside as well. It's probably one of the most simplest thing to draw. Please practice it though. So you have, one of them would be the North Pole, the other one would be the South Pole. So please show the arrow mark as well. That is also very, very important that you show the arrow mark in what direction the magnetic field lines are moving. With that said, let's go on to the next question. Write any 3 important features of the magnetic field lines produced or obtained by a solenoid. Any 3 magnetic field lines, any 3 features that you can think of. Magnetic field lines originate from the north to south pole. Fantastic. Inside, the magnetic field lines move from south to north. Fantastic again. Strength of this field is maximum inside of the solenoid. Absolutely fantastic. Any other answers? They're similar to that of a bar magnet, exactly, Kushagra. You can mention that as one of the important features as well. Any other answers that you can think of, please let me know in the chat box, people. North to south, absolutely. What north to south, Harpreet? Yeah, you have to say that. The magnetic field lines originate from the North Pole and end in the South Pole on the outside of the solenoid. Same at all points. Where? Inside. Same at all points. Inside the solenoid, they are same at all points. Absolutely. Closed in continuous curves. Exactly. Identical to that of a bar magnet, closed in. Absolutely. Fantastic. That's fantastic. Amazing, people. After seeing all this, I actually am very confident that you guys will do fantastic in your board stuff. I'm so confident right now. Looking at your answers, I'm very confident that you guys would do fantastic in your board exams. Please, all I would say is this: you guys are all prepared, because I don't see any wrong answers in the chat box with such a huge crowd. I would only tell you this: please be confident. However confident you are right now, however comfortable you are right now in your exam, also be as comfortable as you are right now. Trust me, now mark my words. You guys would do fantastic in your boards. All right. You just need to focus on that one thing. That's all. All right. That one thing, and that is to stay calm now. That's all. Nothing else matters. All right. Just stay calm and trust me, you would actually pass out with flying colors. You would do fantastically well, because I can see the kind of answers I'm getting in the chat box. I'm so proud of you guys. All that effort that we've put in for one year continuously, has come into effect. I'm so happy for you guys right now. Okay, so with that, with that moment of, appreciation, let's go on to the next question. The 7th question, yet another question which was repeated in board exams 5 times only. 2010, 2011, 2012. I don't know what, I think that 2010, 11, 12 part, pretty much all questions, you see over here also it's 10, 11, 12 itself, here also 10, 11, 12. After that, CBSE decided that, we are copying the same thing, they'll give the same answer. Then they decided to change it. On 2013, they gave a huge blast. Whoever gave their exam in 2013, they would have lost their mind, because continuously they ask the same question, 11, 12 and 10, 11, 12. The people who wrote their exam in 2013 would have been expecting the same questions, and bang, CBSE with a googly ball. Anyways, let's go on to the next question. Describe an activity to show that an electric current carrying wire behaves like a magnet. A very simple activity which can easily do it. Next question is, write the rule which determines the direction of magnetic field held developed around a current carrying straight conductor. Very simple question, guys. Trust me. I mean, if this ever comes in your board exam, just close your eyes and just write that. Just close your eyes and write, because you will still get marks for this. Okay, for the first one, describe an activity that would show a current carrying conductor behaves like a magnet. Very good. Come on, let's go. Imagine there is an insulated copper wire from which current is flowing from point A to point B, and put the compass near it. Near A, you will see that there is a small deflection. Absolutely. That's all. Bacha question all you're asking. Second one, exactly. For the second part of the question, it's basically Maxwell's right hand thumb rule, or in simple words, the right hand thumb rule. Simple as that. So for the first part of the question, I would say, for describing an activity, please be very specific. Since it's a 3-mark question, so you would be awarded 1.5 mark for the first part of the question, and there is 1.5 marks for the second part of the question. So in order to make sure that the teacher do not deduct any marks, not even that 0.5 marks, I would ask you to be as brief as possible, in the sense, mention the things that you're using. Like, you would need a straight current carrying conductor, you would need a compass, you need a insulated copper wire, you need a battery for it, connect all the setup, draw the circuit diagram, draw a proper circuit diagram for it. This would be the insulated copper wire, this would be the battery, and you need a cardboard sheet as well, so you can just drill a hole in the cardboard sheet and then place the compass over here, and when you bring the compass closer to the wire, you'd be able to see some deflection on the wire, which shows that there is a magnetic field created around the straight current carrying conductor. So as simple as that would give you your 1.5 mark. Now for the second part of the question, which rule would you use? Simple. Maxwell's right hand thumb rule. So all you have to do is, imagine you have a straight current carrying conductor. Hold the straight current carrying conductor in your right hand such a way that the thumb shows the direction of current and all the other enveloping finger shows the direction of the magnetic field lines. So the thumb, all the other fingers that are enveloping the conductor shows the magnetic field, and the thumb itself shows the direction of current. All right, so that would be the answer for this particular question. Very simple again, please. But again, be brief. All right, don't just write in one single line. Be a little brief because it's a 3-mark question. So, you get good amount of, they don't deduct marks for nothing. All right, here's another one, guys. Yet again, 2011, this time 2010 missed out on this. 2012, 2011, 12. 13 again missed out, 14 and then 15 this question showed us, came back again. The question is, a metallic conductor is suspended perpendicular to the magnetic field of a horseshoe magnet. All right, please imagine it. All right, a metallic conductor is suspended perpendicular to a magnetic field of a horseshoe magnet. The conductor gets displaced towards the left when a current is passing through it or pass through it. What will happen to the displacement of the conductor if first the current through it is increased? Second, the horseshoe magnet is replaced by another stronger horseshoe magnet. And 3 is direction of current through it is reversed. What would happen in each of these scenarios? Please put it out in the chat box. Each of them would carry 1 mark. So please be a little brief about it. Mention what would happen first, whether it would, what would happen exactly. And then please write in a little about it, at least one line description, so that the teacher knows that you're not bluffing about it. All right. Okay. First one. Absolutely. Now mention that there will be there'll be an increase. So there'll be an increase in the deflection towards what direction? Towards what direction? Mention that also. Towards in which direction is it going to go? Towards right. Towards right. For the first one, is it going to go towards right? Quickly, according to the equation, exactly. Please write that also down. Absolutely. Right. D. If the current is increased, what would happen? Addi, I'm gonna start throwing stuff now. Hey, where's this thing now? Where's the throwing stuff wala thing? I'm gonna put confetti shots. Confetti's on you people for right answer. Hey, it's gonna be towards the left itself, yeah? It's gonna be towards the left itself. Because initially it's going towards the left. Why would the direction change? Why would the direction change? You are not changing the direction of current. All you're doing is increasing the current flowing through it. Why? Huh? Why? Huh? D. Right itself. All, when I said right, all right. So yes sir, right sir, right. D. Punch, no, like punching bag, I'm going to punch you guys. All right, that's the first one. It's going to go towards the left itself, but there'll be greater deflection. All right, for the second one, if the horseshoe magnet is replaced by another stronger horseshoe magnet, what would happen now? Now what would happen? Exactly, Sakshi. Exactly. At least you have someone, like, look at your friends. Look at your friends. Full right. That's all there. Same, exactly. Again, you're going to have an increase. Again, in the same direction. Again, there's going to be an increase. And again, it is going to be towards the left itself. Absolutely correct. All right. For the last one, people, the third one, if the direction of the current is reversed, then what would happen? Exactly. This time, the direction of the deflection would also change. The deflection would now be towards the right. That's all. Simple. All right. And again, please mention that according to the formula, F is equal to BIL. Force is directly proportional to the current. Force is directly proportional to the magnetic field. So mention that. So F is here. You can mention that F is directly proportional to the first year increasing current. Okay. F is directly proportional to I. Here you can mention that F is directly proportional to B. Now here you can mention that the direction is changing because the direction of current is also changing. So according to Fleming's left-hand rule, the direction of the deflection would also change. All right, guys. So that is the end of the 3 markers. Again, fantastic job. So far, so good. But I don't know, some of you guys did make a lot of mistakes in this one. So can we have a thunder? Thunder, because thunder for, I don't know why. I didn't know that this was there until now. So I just want to try it out. What else is there? What else is there? Countdown. 4, 3, 2, 1. Let's go to the next question, people. Let's go. The 4 markers now. Let's go to the last question for today, which is a 4-mark question. This is the 9th question and the last one, which was asked in 2018 CBSE Board Exam. Please, again, give your best at it. The question is, states Fleming's left-hand rule. That is 1 mark. Write the principle of working of an electric motor. That's another mark. C is explain the function of the following parts, which is of an armature coil, the carbon brushes and the split rings. Each of them, each sub question carries 1 mark each. Fantastic question, because again, you know that electric motors are very important. This actually goes to show how important electric motors are. So please put it on the chat box. For the first one, state Fleming's left-hand rule. Let's go. Hello Nidhi ji, what's up? अरे क्या निधि जी, क्या की हाल चाल? So what formula bill NCERT में नहीं है. It's okay, Sakshi can still write it. There's nothing wrong in it. You can mention it. It'll be good. I mean, see, they're not going to cut marks if you know too much. All right. If you put in a little extra, it's okay. It's fine. They'll still give you marks. Don't worry. All right. Yes. Lawrence Force. Arey. Basically, she told that no. As marks inside the solenoid, but sir, she scolded me and told that it's a side. Okay, see, this is a very big confusion now. See, very good question again, Sai. The question is this, guys. Okay, I want your input for this one. See, guys, in a solenoid, there are there's a very huge confusion that I saw in the last thing also. That in a solenoid, when you have a solenoid, let me just draw it out for you guys. 1 sec. Can I just, I'll just take a new slide. Just give me 1 second of your time. Okay, 1 second, guys. Alright, so here's the thing, guys. In a solenoid, you have a solenoid here. I just need your input as well. I want to know what you guys think is correct. Alright, just give me 1 second of your time. I'll just draw the solenoid. Now, here's the thing, guys. So, there's this very important question that has been asked several times, and that is this. That in a solenoid, where is the magnetic field the strongest? Now, can I know in the chat box, where do you think that is? In the chat box? No, before we go to the previous question, can I please know the answer for this one? Because I really want to know what your input is. Inside, poles, any other answers? Poles, inside. Now, again, it is kind of divided. See, if you ask me, just by looking at the magnetic field lines, you can actually say that the magnetic field lines inside is actually a lot more stronger, because the reason is, if you look at the magnetic field lines inside the solenoid, the magnetic field lines are very, very close to each other. And you guys know that the degree of closeness in a magnetic field lines show how strong the magnetic field in that region is, right? We've studied that. So it obviously makes sense for us to say that inside the solenoid is actually the correct answer. But then, there is another confusion here, because some places, especially when it comes to NCERT and CBSE, there's a theory that the magnetic field lines near the poles are strongest. Why? Because if you talk about a bar magnet also, we know that the solenoid's magnetic field is very similar to that of a bar magnet. In a bar magnet, we always say that the magnetic field lines near the poles are stronger. So there is a slight bit of confusion here. All right. Now, again, if you ask me, I would say that it's a little more stronger over there. See, it's uniform. See, the magnetic field inside the solenoid is strong. It is also uniform in nature. Because the magnetic field lines are parallel to each other, it is uniform, and it is also strong because they're closer to each other. But again, see, guys, I don't want you guys to get less marks, or because of me, I don't want you guys to get the wrong answer and regret it later. So what I would suggest you to do is, please get the input from your school teachers also about this one, because there is no real clarity, because it's very clearly inside the solenoid. But then CBSE, there are few mistakes in NCERT which we have pointed out several times. Even in the chapter light, there are a lot of mistakes that NCERT has made. So this could be one of those. So I would suggest you to ask your school teachers, especially if there is anyone who knows, who you know have corrected, who have actually been the invigilator, or who have been the examiner in CBSE, who have actually corrected the CBSE board exam papers. If you could ask them, that would actually give you more clarity. Because if you ask me, it's inside, but then again, you need more clarity on it. All right. Exactly, that's what you have to follow NCERT. So in NCERT also, it's not clearly mentioned, right? It's not directly mentioned that inside, or it's not clearly mentioned. Have you guys, so when you read NCERT, has it been mentioned anywhere? Maybe in other publications, have you guys seen this anywhere? If you guys have, please let me know. Please let me know so that even I can correct it. If I am wrong, you have to correct it. Yes, please let me know in the chat box if you guys have ever seen this before. Because if you ask me, I would say it's inside itself. But again, yeah, exactly. It's not mentioned in NCERT also. So there's a slight bit of confusion here. Again, it needs a clear clarity from the board itself, because even the answer key, you guys know that when the sample papers came also, some of the answer key itself was wrong. So there are a lot of mistakes. So I really don't know what to suggest here. So I would only say this, please ask your school teachers, get their input. It would be a lot more better. You would have better clarity then. All right, please do that. Okay. I know, exactly. I know it's uniform. See, it is definitely uniform, but it's also stronger because it's very close to each other, no doubt. See, the thing is that in a bar magnet, the magnetic field lines are inside. Since it's a solid structure, you can't really feel it. You can't really experience it. But a solenoid, on the other hand, is hollow. You can actually experience this, you can actually experience it. That is why we place the soft iron core inside the solenoid. We place it inside the solenoid because that is what it gets magnetized. No, it becomes stronger. It becomes a stronger magnet then, right? But again, please get more clarity from your teacher for this one. All right, for this question alone, I would request you to get more clarity from your teacher. All right, okay, let's go on to the last question. Now let's finish it off with a bang. Here's a question. State Fleming's left-hand rule. Write the principle okay, Fleming's left-hand rule is very simple. I'll just state it out anyways. If you have confusion on it, we have actually made the Prodigy series on this, guys. So please go check it out. You would actually understand and enjoy the series. So, okay, what is Fleming's left-hand rule? So according to Fleming's left-hand rule, if you take your left hand and extend your thumb, index finger and middle finger such a way that they are all perpendicular to each other. You would see that. Let me just make the screen a little bigger so you can clearly see it. Such a way that they're all perpendicular to each other. The thumb shows the direction of force acting on the current carrying conductor. What direction the force is, that is shown by your thumb. Your index finger shows the direction of the magnetic field. What direction the magnetic field is going, that is shown by your index finger. Last but not the least, your middle finger shows the direction of current. So this is what is basically your Fleming's left-hand rule. All right, very simple. But again, in your own words, please state it. Again, the key words are what is more important. So focus on that. Now, what principle does the working of an electric motor works on? Please let me know in the chat box, people, quickly. Principle is magnetic effect of electric current. Wow, wow, Nidej, wow, wow, wow. So when the current carrying conductor is placed in a magnetic field, exactly, Sai, exactly. Absolutely fantastic, absolutely fantastic. The principle behind this is basically Lorentz force. That is when a current carrying conductor is placed in a magnetic field, that conductor will experience a force, and that is the basic principle on which it works. Let me just that is the basic principle on which it works. All right, now talking about the functions of the following parts. What does an armature do? Come on, guys, in the chat box. Let's go. Yes, Nidhi. Very, very smart you are. So when a conductor is placed, exactly, Kushagra. Fantastic. Absolutely. Arre, Varsha ji. Awesome. Who was Lawrence? Lawrence was my neighbor. Lawrence was the name of the scientist. Lawrence was, was the name of the scientist. Who was Lawrence? It's all right. Lawrence Ayton is my neighbor in Kerala. Lawrence Ayton makes nice chicken curry and all. Every Sunday, I get nice chicken curry smell from Lawrence Ayton. Armature coil rotates, exactly. Okay, so you can mention that armature coil is basically something which is placed between it's an insulated copper wire which is placed between a magnetic field, which, because of the Lorentz force, when current is flowing through it, because of Lorentz force, starts to rotate. So that is what is armature coil. Please be brief. All right, it's a 5-mark question, so please be a little brief. All right, what is the function of the brushes? Let's go. Who is Anoop sir? Anoop sir is basically the neighbor of Lawrence Ayton. All right, Lawrence Ayton neighbor is Anoop sir. Again, we are neighbors, no? Like, Too much. Alright, let's go. Increase the area of absorption of current. What does that, Harpreet? Conducting carbon brushes connect the external circuit to the armature coil. Yes, absolutely. You can mention that. So carbon brushes are basically the connecting link between the external circuit, that is the battery and the switch, to the conducting coil and the split ring, that is the armature coil and the split ring. So though the external circuit is connected to the internal circuit through this small thing called the carbon brushes, which basically stays in contact with the split rings pretty much the whole time. All right, not the whole time, but yes, they do stay in contact in order for the current to flow. All right, last but not the least, people, what is a split ring? Let's go. What is a split ring? In the chat box. Can we go, people? Let's go. And yes, guys, before we go to the final this thing, do not forget to subscribe to the channel, hit the like button if you're enjoying the video, and if you guys want more videos like this, please let us know in the comment section as well, so that we can also do more such series to help you guys out with your 10th standard board preparations. All right, split rings act as a commutator. Fantastic, Sai, fantastic. Reverse it. Exactly. So split ring is basically also known as a commutator because it actually helps in changing the direction of current every half rotation. So that is the most important thing about the split ring. You can also mention the fact that the split ring connects the internal, that is basically the armature coil, to the carbon brushes as well. All right, so those are all the things for today, all the questions for today, people. So let me know in the chat box, people, did you guys enjoy the questions? Give me your oh yeah in the chat box. And for being a fantastic crowd, can we have Biggie? Congrats, guys. Fantastic. For being a fantastic crowd, for answering all the questions, for being as awesome as you guys have always been since the start. Thanks a lot for that, people. So we really appreciate it. The whole family of Vedantu, we really appreciate your love and support. Keep doing the same thing. Keep supporting us. Keep loving us the same way. We also love you guys back. Oppa Sarangeyo. Now, with that said, before we end today's session, I would also like to mention this very important thing for all the students who are still looking for a preparation plan. With all this thing going on, you still want something, that one last touch, that magic touch that is going to help you get you across the line. If you guys are looking for something for that, of that sort, then AI live classes, that is your Drona Reloaded, is going to be something which is going to change your life. For all the students who are currently in 10th standard, who are going to be giving your exams in the next couple of days, you guys, if you're still looking for a revision plan, you're still looking for the last magic touch, this is the one for you. Drona Reloaded, with just 990 rupees, you would be getting in-class doubt solving, live quizzes, live hotspot, live polls, milestones and leaderboards, everything and anything that would actually help you with your preparations. We would be doing that for you on this amazing platform of Vedantu. Drona Reloaded is for you guys. Now, if you're someone who is currently in 10th standard and you're looking for your 12th preparation, 11th and 12th preparation, we've got you covered on that as well, guys. AI Live, again, back with a bang, where you have in-class doubt solving, amazing level of quizzes, hotspots, leaderboards, everything that you love about the platform, with the test, with constant SAM and care support, that is a student account, mentor and care support, with where you can reach out to them at any point of time, micro courses, and on top of all of that, with Vedantu's improvement promise, there is no better place to kickstart your 11th standard preparations. The VIP promise is something which actually blows everyone's mind away, because VIP states that if you attend 75% of the class, let's say you enroll into NEET or JEE program, and if you do not get the desired marks or the desired rank, you can actually claim your money back. And guess what is the price of all of this, guys? AI Live, for 2-year course, for 2 years, where you're getting your 11th and 12th preparation, along with something as massive as your JEE or NEET preparation, all of which you're getting for just 13,500 after you apply my coupon code AME Pro. Full school syllabus, over 1,000 hours of teaching on this platform with study materials, test, assignments, mentors, everything and anything for you to score good marks to get the rank that you want. Because this year alone, people, we have created more than 1,400 IIT JEE students. That means they would be entering into IIT JEEs in this particular year. Over 6% of students going to IIT JEE would be from Vedantu. And you are getting a chance, that assurance with Vedantu Supreme Promise, that you would also do well in those examinations. Everything, all your favorite teachers, you would have Amit sir, Shivam sir, Kumar sir, all from IIT itself. So you have people who have been to IIT teaching you how to crack those exams. That's what you're getting out of here. 13,500, very, very reasonable price. In fact, it's less than reasonable, because if you ask me, again, I'm telling you people, when I was in 10th standard, I used to pay 500 rupees per subject, right? Per subject, it was around 500 rupees per month, not for the whole year, per month. This, after that, and I'm talking about like 10, 12 years ago, and now it is actually less than what it was back then. It is just fabulous. We have actually managed to do that in an amazing sort of way with the intervention of technology. So yes, my coupon code is AME Pro. So if you guys want to kickstart your preparations of your 11th and 12th right now, along with your 10th standard revision, this is the course for you. 13,500 is the course price. All right, so that's all from my side, guys. That is all I have to say. That's all from my end. Now, if you have anything to ask me, any doubts that you have, please let me know. You can also see a small little scroll bar that you see at the bottom. There's a small little number that you can see over there. Now, if you guys want more information about AI Life, all you have to do is go to the description of this video. You'll find the entire message also that you have to type. All you have to do is go to the description. You'll find my name is whatever it is, whatever your name is. My name is Atul. My name is Himanshu. Put it down over there. Then I am from whatever grade you are in right now. You're in 10th standard. So put it as 10th standard. And you want to join the family of maybe NEET or JEE, whatever you're looking for, put that down as well. And you can also mention that I am texting after watching Anoop sir's session, and you're good to go. All right. So all you have to do is enter that message, and you would be getting a call back from the experts to explain what exactly is AI Life and why do you even need to choose it. All right. So that's all from my side, people. That is all the inputs from my end. If you have anything to ask me, please let me know. Hi, Imtisal. What's up? How are you doing? Welcome. Yeah, definitely. Subha Badmashi. Why not? Absolutely. For that, I don't have to sell my kidney. That's a good thing. 13,000 though I can afford. I don't have to sell my kidney for that. All right, so that's all from my side, guys. That's all from my side. Thanks a lot for being an amazing crowd. Once again, thank you for being so good. So yes, once again, let's end this session with another door. That's all. That's all for today. Bye, people. Take care. Have a great evening. I wish you guys all the very best of luck for your future, for your exams. Do well. Shine like a star. Shine like a diamond. Catch you guys soon. Take care until the next time we meet. This is Anoop signing off. Have a great night. Peace. See you all. Take care. Bye-bye.